Last but not least, review part 4. Review part 4 is the final one. It's on units 5 and 6, and once you're done with this, you've got all the answers to the packet. All you gotta do is write them down for 30 free points. We do the same thing if you're in class. We spend days going over this. All you gotta do is be ambitious enough to write it down, 30 free points. So we're going to start with Lewis dot structures. Now, I know you can't draw dots on the test, but what you need to remember is that the number of dots is equal to your number of valence electrons. So when I'm doing the structure here for argon, group 18, 8 valence electrons, and I pair them up, kind of like Hund's rule, 2 on a side. Awesome. If I'm looking at bromine, group 17, what I'm going to see is something really similar to that, except I'm missing 1. Strontium, group 2, we'll give him 2, but they're not on the same side. All right. Hey, look, beryllium's in that same group, group 2. Potassium, group 1, he gets a single dot, and this probably said K on yours also. I was looking for krypton to prove to you again. Group 18 will have 8. And that's Lewis dot structures. Now, if these Lewis structures take longer than I think, we'll do 2 videos. I don't know. The equations part that's below this, we're not going to do the equations. We are going to do the balancing part. We're not going to write, but we're going to balance. So I'm going with it. You can count valence electrons, sort of. I'm going to do a quick count instead. Carbon's 4. Fluorine's 7 each, so 4 of them's 28 for 32. Carbon always goes in the middle. And when I've got 4 things bonded to it, I draw that with them bent down just a bit. Fluorine always wants 1 bond and 6 dots. And that's going to be a tetrahedral molecule. Carbon in the middle with 1 of them is always a tetrahedral molecule if you've got 4 things bonded to it. Carbon with 4, tetrahedral. Here's carbon with 2. Carbon's going to give me 4 valence electrons and oxygen a total of 12 for 16. Carbon goes in the middle, and right off the bat I get suspicious because carbon has to have 4 bonds. I think about it and I know carbon and oxygen can double bond. Now carbon has the 4 bonds it likes and oxygen has the 2 it likes. 2, 4, 6, 8 used. 2, 4, 6, 8 to fill up oxygen. Molecule's a straight line, molecule's linear. I don't think I'm drawing SF6 again. It looks like a flower. Sulfur's in the middle. You put 6 fluorines around them. 6 dots per fluorine. Octahedral. It's on every practice you did all year. I think this one is too, but at least it's quicker. 2 electrons from hydrogen plus 6 from oxygen is 8. Oxygen in the middle with 2 hydrogens. Moderately cheating because I know what the geometry is. You might remember too, we've done it a bunch. 2, 4, and remember hydrogen's good. 1 bond, no dots. Oxygen likes 2 bonds and 2 pairs of dots, and they make it bent. See, this isn't too bad. C2H4, I'm going to put that in there. I'm taking out that SF6. I got 8 electrons from carbon plus 4 from hydrogen. 12 electrons is not a lot. I'm going to set this up with the 2 carbons together. I always make a chain. Since I've only got 4 hydrogens, I'm giving each one 2. And those are some sad carbons. Not a fan. Going here, I'm going to double bond 2, 4, 6, 8, 10, 12. Now, if I'm looking at this, it's not really drawn in a correct geometry. So I want to redraw it. This one's tricky, and I wouldn't have you do this on a test. But what you need to see here is that both carbons would be trigonal planar. Because if you look at one at a time, each one is trigonal planar. NH3, 5 electrons from nitrogen, 3 from hydrogen. I've got 8 electrons to use. I think this is going to be great because nitrogen loves to have a pair of dots and 3 bonds. So it's going to have, there's its 3 bonds, and there's its pair of dots for trigonal pyramidal. If these structures are a little messy, honestly, Google molecular geometry of, or Lewis structure of, and you'll be able to see NH3. You don't even need to know the names, and it'll show you what those are. Going back to the chart with the shared pairs and the unshared pairs and the bond angles now. That was a little bit backward, just so that I can look at those now that we have some examples. If you look at linear, this would be better said as shared domains, because linear has two shared domains, 1, 2, and no unshared pairs on the central atom. Linear's bond angles are 180 degrees. That was nice. We have a trigonal planar here. Just look at one side of it. What you've got is 3 shared domains, no unshared domains, and bond angles of 120 degrees. Everybody's friend tetrahedral, 4 shared, 0 unshared, and bond angles of 109.5. Trigonal pyramidal, there you go. He looks like he's got 3 shared pairs and 1 unshared pair. I won't ask you the bond angle on this one, but it's the same as tetrahedral, 109.5. I wouldn't put too much thought into the bond angles here. I'm more concerned with the geometries. The bent I showed you is 2 and 2, and also 109.5 because it came from tetrahedral. All good there. We didn't see a trigonal bipyramidal here, but it would look kind of like that. It's usually phosphorus in the middle. I can't think of any other example. 5 shared, 0 unshared. Just so we've got them, I'll give you the bond angles. The bond angles are 120 around the middle and 90 from the top to the middle or the bottom to the middle. Good to know. Fill it in. Don't worry about it for your test. Octahedral is the one I refuse to draw. 6 shared, 0 unshared, and bond angles of 90 degrees. So that's the end of your Lewis structures and molecular geometry section. And honestly, I'm afraid I'm going to run a little bit over, so I'm going to stop. I'm going to put up those equations on my board, and then we're going to balance them together. The reaction section below that, I'm not going to do. I want you to try it, and I'm going to attach the answers. There's no place on the final where you have to write anything from memory, but it's a nice nomenclature review. It looks at some balancing, so it can't hurt you to try. I give you the answers to that section, and we'll go over the limiting reactant stuff at the bottom in the second video. So there's going to be our Day 4 Part 1 and a Day 4 Part 2.